In math today, boys and girls, we're going to continue studying fractions. We're going to begin today with a video talking about our success criteria. And I want all students focusing their attention, thinking about what are we going to do today.
Today we're going to be working on Math Learning Target 3 and S3. It sounds like a lot, but it's actually quite simple. The standard reads that you can understand a fraction 1 over b as the quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction a over b as the quantity formed by the parts of size 1 over b. Our denominators will be limited to 2, 3, 4, 6, and 8. I know that sounds like a lot, but really it's what we've been working on. We can understand that a shape can be formed into 1 over b. Let's say that b is equal to 4. So this shape I'm going to divide into 4 equal parts. And this unit fraction right here is 1/4. So that's that first part right here. We also can understand that AB as a quantity formed by parts of size 1b. So if 1b is 1/4, then on this shape here, this is 1/4 plus 1/4, which, as we know, is equal to 2/4. This is what we have been working on. It sounds a lot more complicated than it really is.
All right, we're going to stop right there. Boys and girls, the first thing we're going to do today is we are going to take some notes in our math notebook, purple tape, and you also need a pencil. We're going to take some notes today on how we can use unit fractions to help us make a different fraction, a fraction with a numerator other than 1. Go ahead and get your notes ready and we'll do that together. Okay, we're going to title our notes Fractions because we are continuing taking some notes on fractions. Go ahead and title your notes with me, please. Boys and girls, we have really been focused on unit fractions. We know that a unit fraction is one part of the whole. It's the name of each part. So today we're going to look at some examples where our numerator is different than 1. So now we're going to talk about fractions that are not unit fractions. We're going to draw some models together. Draw a rectangle model with me. And we are going to partition this first model into fourths. We're going to partition this model into fourths. There are two ways to partition into fourths. Today I'm going to do it like this. This is one way to partition into 4 equal parts. Please partition your model into fourths. We know that each part is 1 out of the whole, so we can label the unit fraction. We know that each part is called 1/4, 1/4, 1/4, 1/4. There's my fraction robot. 1/4, 1/4, 1/4, 1/4. We have now labeled each part. Check that your model matches mine. Let's pretend that this model represents a pan of brownies, and I partition the pan of brownies into 4 equal parts. Let's pretend that I eat 1, 2, 3 of the parts. I want you to shade 3 of the parts, just like I have. Mrs. Rinalé has eaten 3 parts of the whole. So we can say that Mrs. Rinalé ate 1/4 plus 1/4 plus 1/4. When we do 1 plus 1/4 plus 1/4 plus 1/4, we write that as 3 1/4 or 3/4. Show your work just like I have. Let's do a second example together. Let's pretend that we have a pizza that we are going to share. Draw a circle model with me to represent a pizza. Let's partition the pizza into thirds. We want 3 pieces of pizza. To partition into thirds, we draw a line down the middle, halfway. Then we draw an upside down letter Y. I have now partitioned into 3 equal parts. I know the unit fraction is the name of each part. I know each part has a numerator of 1 because it's describing one part of the whole. My denominator tells me how many parts are in the whole. I know there are 3 equal parts in this one whole. Check that your model is partitioned and labeled with the unit fraction. When we look at our pizza, I'm going to say that Landon ate this piece. Landon ate this part of the pizza. And Kellen ate this part of the pizza. I want to know how much pizza was eaten. Well, I know that Landon ate 1/3. So 1/3 plus Kellen ate 1/3 of the pizza. So I add another 1/3. When I combine those together, we have 2 1/3. We write that as 2 fraction bar 3. 2 1/3. Sometimes people say 2/3. Check that your notes match Mrs. Renalé's. Okay, 3rd grade, now we are going to switch to our Seesaw task together. Please join me on Seesaw. You will click on Activities, Assign to Class folder, Blue, Math. And today our task is called Lesson 12-2, Fractions and Regions. Lesson 12-2. Go ahead and open this task with me, please. On slide 1, we have a warm-up to get our brains going with fractions. Here we have a word problem. I want you to show your knowledge on slide 1 as a practice. I'm going to be the reader, you are listening, and I want you to show your work right here on the model. Pat made a garden in the shape of a rectangle and divided it into 4 equal-sized parts. She planted flowers in 3 of the parts. Draw a picture of what Pat's garden might look like. I want you to take 1 minute to reread the problem and show what Pat's garden would look like inside the rectangle. You have 1 minute to reread and draw and show your model. Okay, we are going to go over what this would look like. Pat divided the garden into 4 equal-sized parts. So you could partition in 2 different ways. Right now, I would like to partition it like this. Next, it says she planted flowers in 3 of the parts. So there would be flowers in this one, flowers in this one. Right now, I have flowers in 2 of the parts. I know the text tells me 3 of the parts, so 1 more part needs flowers. Now, Pat has flowers in 3 of the parts. This represented with a fraction would be 1/4 plus 1/4 plus 1/4. And when we combine those together, we would call it 3 1/4 or 3/4. Great job. We're going to go to slide 2 and we're going to look at another example together. Join me on slide 2. On slide 2, I see a picture of some food. I know we all know about food and we have to share the food with our family at home. So let's read about what this example says. Mr. Peters served part of a pan of enchilada casserole to a friend. What does each part of the whole pan of casserole represent? What part was served? What part is left? Okay, so this is a real life situation. When we make a pan of food at home, sometimes some of it is gone. Sometimes there are leftovers. Fractions can help us know what's left and what was eaten. We're going to watch a video. We're going to follow along with it as we learn about fractions and their part to a whole. Boys and girls, I'm sorry, we don't have sound on this video, so we're going to skip this video today. I apologize about that. We will just talk through the example today, and we will do it together. So it says to look at the pan, and then we're going to read some about this problem. It says the whole casserole is divided into 6 equal parts. Let me show you what I'm looking at right here. The whole casserole is divided into 6 equal parts. Each part is 1/6 of the whole. So this piece is 1/6. This piece is 1/6. This part is 1/6. This part is 1/6. Here I am as the robot. Here I am repeating myself. 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. When you put all of them together, it equals 1 whole. We talked about that last week. So now let's think about how many parts were eaten. If we look at the example, I notice that there are 2 pieces missing. This part has been eaten, and this part has been eaten. So how many parts were eaten? Well, 1/6 plus 1/6 equals 2 1/6 were eaten. Somebody already ate 2/6 of the enchilada casserole. How much casserole is left? We can look to see how many parts are still there. Let's highlight those in a different color. I notice that this part is still left. This part is left. This part is left. And this part is left. If I add those together, that's 1/6 plus 1/6 plus 1/6 plus 1/6. If we combine them all together, I count 1, 2, 3, 4. 4 1/6. Casserole is left. Great job looking at the example with me. We are now going to practice them together on slide 3. This slide says, with your teacher. Let's start with problem number 2. Mrs. Patel made a cake. Here's the cake. Look at the model. What fraction of the whole cake does each piece represent? Let's go back to our question and focus on what it asks. What fraction of the whole cake does each piece represent? I'm going to get my drawing tool ready to label. And I know that each piece means unit fraction. I know that a unit fraction is any fraction with a numerator of 1. So I'm going to label each part with a numerator of 1. But what's my denominator? My denominator tells me how many parts are all together, how many parts are inside the whole. So let me count to see how many parts would be in the whole. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 parts that make up the whole. That tells me my denominator is 8. So each piece is 1/8. Mrs. Patel wants to know, what fraction does each piece represent? 1/8 is the correct answer. Check that you have your cake labeled and your answer written down. Now we are going to look at problem 3 next, the second problem that goes with this cake problem. Problem 3 says in the pictured exercise 2, that means problem 2, how many 1/8 pieces were eaten? What fraction of the whole cake was eaten? Okay, so for this one, boys and girls, we have to use the cake from problem 2. This cake model will help us in problem 3. So let's look at the first question. How many 1/8 pieces were eaten? So let's focus on the cake and let's see how many pieces were eaten. I count 1, 2 pieces. My question says, how many 1/8 pieces were eaten? So I can record, I'm going to type it actually, changing my mind here. I'm going to record that 2 pieces were eaten. Notice that I'm answering in a complete sentence to answer the question. How many 1/8 pieces were eaten? I looked at the model and I counted 1, 2 pieces were eaten. Then I typed my answer. You may do the same and type 2 pieces were eaten. In question 3, we have 2 parts to the question. The first one said how many pieces were eaten. We just answered that. Now it says what fraction of the whole cake was eaten. What fraction? So the first question asked me about pieces. The next question is asking me how many fractions. So let's go back to our work from problem 2. We know that each piece is 1/8. So if 2 of them were eaten, we can add 1/8 plus 1/8. So let's record that under problem 3. 1/8 was eaten plus another 1/8 was eaten. When we add those together, it equals 2 1/8. Notice how my denominator is the same. When we add fractions together, our denominator does not change. 1/8. Go to slide 4. Next, please. On slide 4, we have another model. Take a minute and look at the model. Think about what you notice in this model. What do you notice? Okay, now it's time for us to answer some questions using this model. Let's start all the way to the left with the first question. It says, how many 1/3 parts are blue? So we know that the unit fraction is 1/3 because it's divided into 3 equal parts. So how many parts are blue? I count 1, 2 parts are blue. 2 parts are blue. You may type it if you prefer. 2 parts are blue is the first answer to our question. The next question in the middle says, what fraction of the whole is blue? So because this word asks me what fraction, my answer is going to be a fraction. Okay, so what fraction of the whole is blue? Well, I see we have 2 parts that are blue. I have to add 1/3 plus 1/3 to see what fraction is blue. 1/3 is blue plus another 1/3 is blue. When I add those together and combine them, I know I have 2 1/3 that are blue. Now I know what fraction of the whole is blue. The final question asks, what fraction names all the parts in a whole? What fraction names all the parts in a whole? Don't forget, when it asks you what fraction, my answer is going to be a fraction. Okay, well, let me count all the parts. I know I have 3 parts because I've got 3 equal parts. So I have 1/3 plus 1/3 plus 1/3. I know that if I add all of these together, that will equal the whole. My question said, what fraction names all the parts in a whole? So now I have to add them all together to see what that fraction is called. I know that if I add 1/3 plus 1/3 plus 1/3, I will have 3 1/3s. We have talked about this a little bit, how this is equal to 1 whole. Notice how every time you're adding fractions, your denominator will stay the same. All of the denominators are the same. It's only the numerators that you add together. Because there's still only 3 parts in the whole. I'm not changing how many parts are in the whole. Great job with our note taking today. Let's talk about what your independent work is today. Everybody go to slide number 5. Slide number 5 is where we will begin today for independent work. Okay, here you have 2 problems, and I notice some information here that will help you if you want to look at it. You are going to answer these questions about the model. So these go with number 7. These questions go with number 8. You will practice telling me the denominator of the fractions, what the unit fraction is, the number of parts that are blue, and then the fraction of parts that are blue. Don't forget that you can look back at the work we've done together. Slide 4 is showing you all of these answers, asking you how many parts are blue, what fraction is blue. You're going to do the same thing on number 5, just with some new models. Slide number 6 is the same thing, just with some new models. When you get to slide number 7, this is more of a challenge. It asks you to create a model by drawing a circle that shows 6 equal parts. Shade more than 3/6 of a circle, but less than 5/6 of a circle. Then you're supposed to answer, what fraction have you shaded? I would like all students to do pages 5, 6, and 7 on your own today. Don't forget to reflect on your math goals today. Tell me how you felt successful with today's work or what you need practice on. When you are done, you will push the green check to submit.